Okay, kids, we're back here, section 2.5, practice question 5. Let's read this wonderful question. According to Newton's third law, when a horse pulls on the cart pulls back with equal force on the horse. That even rhymes. If in fact the cart pulls back on the horse as hard as the horse pulls forward on the cart, how is it possible for the horse to move the cart? Oh my goodness, it's kind of a conundrum. Let's figure it out. So here is my drawing of the horse. Pretty good drawing, isn't it? Yep. And here is my drawing of the cart. I want everyone to pay attention here. This is one of those classic physics problems that teachers like me have been putting to their kids forever, since I was a student, even before. Okay, so the red one, this is the cart. That's the free body diagram for the cart. The purple one is the horse. Bet you didn't know I spoke horse. Okay, so here we go. There's the force of gravity on the horse. There's the normal force on the horse. There's the force of gravity on the cart. There's the normal force on the cart. Okay? Now look. What is pulling the cart forward? Well, it's the force. Now listen to me carefully here. The force of the horse on the cart. I'm just going to call it force horse on HC. You guys okay with this? But if that force there exists, by Newton's third law, there has to be the other force, the matching force, the pair, which is the force of the cart on the horse. And we know that the force of the cart on the horse is equal in magnitude, but opposite in direction of the force of the horse on the cart. Now, one thing to be very specific here, okay? This force here is on the horse. This force here is on the cart. They're on opposite objects. Please never forget that. So the question is asking, if these two are the same, how could this ever move forward? Well, that's easy. Right here, and I'm going to draw it nice and big and thick to emphasize the point here. Right here is what I'm going to call the force of the horse stepping. Right? Doesn't the horse step on the ground and pushes on the ground and then the horse goes forward? This force is so huge. This force here, force stepping as the horse steps, is so huge. It pulls, it's much bigger than the force of the cart on the horse, much bigger. And it pulls the horse forward. Well, as it pulls the horse forward, right, the horse and the cart are connected, right, by some mechanism, right? So it's so big, it pulls the horse forward and it pulls the cart forward. But that doesn't mean that these forces aren't equal. They are equal, but they're on opposite objects. So in order to get this thing moving, all I need is a really big force from the horse stepping on the ground and pushing themselves forward. Does that help? Okay. There we go. Vaya con Dios.